In the name of God. This is Maria Behavi. I'm assistant professor of Institute of Higher Education and also invited lecturer at the University of Georgia. I have been researching in production of recombinant protein since 2010, so I have been invented several recombinant vaccines. Twice of them is patented, but third of them is in process. Today we are witnessing a spread of cancer, and there are several ways to cancer treatment. Next way is biological drugs, and such as recombinant protein and vaccines. So the purpose of this invention is to produce the first multi-epitope recombinant proteins based on cytokine genes for cancer immunotherapy. Cytokines classification to interleukins and chemokines, so we choose CC-21 and CC-19 as chemokines. These chemokines has the potential role in immune cells and lymph node homing, and also ability to chemotherapy and dendritic cells. And by increasing CD8 positive T cells, they can use to reduction and detection of viral infections. Also, they have DCCL motif to bind to CCR7 receptors. The other cytokines is interleukin-1 beta, and the epitope of this interleukin without any inflammatory response, as also it has it can increase the immunogenicity of protein antigens, and also produce antibodies and use as fibroblast proliferations. The other cytokines is GM-CSF is used as growth factors, and also it can increase the myocytes and the granulocytes. So, to synthesize this construct, we use the best epitope of these cytokines, CC-21, CC-19, GM-CSF, and interleukin-1 beta, and link together with some rigid and flexible linkers. After synthesize the design and synthesis of recombinant protein, we optimize the based on E. coli, and use some in silico analysis. For example, molecular dynamic simulation and molecular dynamic to know about the binding affinity of this recombinant protein and CCR7. And also RMC and RMS was used to know about the flexibility and the stability of this recombinant protein. We insert this synthetic construct into vector and E. coli and colony to E. coli, and to know about if this gene expression correctly, we use real-time PCR assay, and we purify this recombinant protein by nickel column, and also we evaluate this recombinant protein by vessel-emulating ELISA, and calculate the total soluble protein of this recombinant protein. To know about if this recombinant protein expressed correctly in E. coli, we use FTIR and the multi-epitope mass spectrometry assessment. So after detection the structure of this recombinant protein, we use some functional assessment, such as entity assay, chemokines assay, and scratch assay. Entity assay used to know about the toxicity effect of this recombinant protein on cancer cell lines, and also to know about the migration of cancer cell lines with recombinant protein. We use a scratch assay. And you see in this figure, this recombinant protein has anti-metastatic effect on cancer cell lines. Also, to detect if this recombinant protein and cancer cell line can attract to each other, we use chemokines assay and Boyden chamber assay. Also, flow cytometry was used to confirm the binding of the multi-epitope recombinant protein to CCR7 on PBMC cells, and know about the binding specificity. Okay, the purpose of this invention is produce the first multi-epitope recombinant protein as a vaccine, and it has a beneficial advantage with low cost price and without any inflammatory response, and it can be used as biomarker for cancer screening, and also immunize the patient before immunotherapy, before cancer immunotherapy. Thanks for your attention.